Hi everyone, you're welcome to the second part of this lecture, which is going to be on logic. When we talk about logic, people have different meanings, different expectations, different understanding, different interpretations. But Oxford says that logic is the science of reasoning. It is proof, thinking, and inference. So it's not too different from our reasoning that we just looked at. So when you talk about logic, you have a set of formal languages which represent information such that conclusions can be drawn from that kind of information. For example, if alpha is true, so beta is true. Or we can say that where beta is true, alpha is also true. Okay? This one is represented as A entailing alpha entailing. This one is represented as alpha entailing beta. Components of a logic system. There are three major components of any logic system at all. You have the syntax. The syntax will represent the legal expressions in that language that you are talking about. For example, if you want to be in maths, x plus 2 will be greater than 3 versus x plus 2 minus the less than sign. You would see that x plus 2 greater than 3 is a valid legal expression in mathematical language. But if you say x plus 5 minus less than, it doesn't make any sense. So syntactically, that expression is wrong. Then you talk about the semantics. The semantics will tell you the meanings of the sentences, whether they are true or not. And so if you have x plus 2 greater than x, you'd see that x plus 2 will be greater than x. Then if you have 3 minus 1 being equal to 0, it doesn't make any sense. So the meaning of that is not proper. It is not true. It doesn't have a proper truth value. Yeah. So, and then you have the third thing, be the inference mechanism. The inference mechanism is like the reasoning that we recently looked at. So we decide what follows validly from a logical set of sentences. Those are the components of any logic system at all. Then we can come to propositional logic. It is the simplest logical system that you have. It is made up of basic simple symbols, and those are what we call the logical constants. A logical constant can be true or false. Then we have the propositional symbols. Propositional symbols are like the sentences being used in the propositional logic system. They could be represented by alphabets, they could be represented by numbers. We can have P, Q, R, or S, and each, for example, P could be a full sentence or P could be a set of sentences. Then we have the connectives. We have the and, we have the or, we have the not, we have the implication, and then we have the by implication. When you use the connectives and then you use the propositional symbols in conjunction, you get what we call complex sentences in propositional logic. Now let's look at sentences in propositional logic. A literal will be an atomic sentence which is either a positive P or a negative P. Remember, we have said that P is a literal and P is one of the constants, and it could be a sentence. So we could have a positive something or a negative something because, again, we said that we have the true or the false bits. Then we have the logical constants which are true or false, and they could be sentences. So then, if P and Q are sentences, assuming that P and Q are sentences, when we use the and symbol and we put P and Q together, we are carrying out what we call a conjunction. If we say P or Q is a sentence, then we are looking at the disjunction of that. This is very similar to conjunctions and disjunctions and negation that we saw or that we have seen in maths. Having the negative of a P being a sentence is negation, and then we have implication where P can imply Q also being a sentence. Then we have P by implication Q, which could also be a sentence, which is a biconditional sentence. Examples of sentences in propositional language. So you can have P, you can have a P and a Q, you can have a P or a Q, you can have a P or Q implying an R, and the result of that could be true or false depending on how you build your truth trees and then the truth values of those individual sentences. You can use parentheses to avoid ambiguity when you are constructing very complicated sentences in propositional logic. Semantics. The meaning of a logical sentence is based on whether it is true or false. Remember, I said that if we have P being a sentence and you have Q being a sentence, the final value of a P implying a Q will depend on the truth values of P and Q individually. So the semantics will tell us the logical sentences, which are going to result based on whether those individual sentences or those simple sentences are true or false. Now, whether P is true or not depends on what P is. Again, whether P is true or false depends on what P represents. Depends on what P is representing. Some propositions will always be true and others will always be false. And some could be either true or false depending on a current state that an agent encounters. Now we say that P and Q is true if and only if P is true and Q is true. So when you have two true sentences and you are doing a conjunction, by all means, the resulting statement will be true. Again, if you have a P or a Q, the resulting statement will only be true if P is true or Q is true. Meaning that if you have P being false and Q being true, the result will be true. If you have P being true and Q being false, the result will also be true. So either one can be true and the resulting statement will be true. Negation of a sentence will be true if and only if the initial value of that sentence was false. So that it is the same as saying negative of a false is true, which is logically correct. P implying Q will be true if and only if P is false and Q is true, or P and Q are both true or false. What that means is that if P is false and Q is true, then P implying Q will be true. If P is true and Q is true, then P implying Q is true. Or if P is false and Q is false, then P implying Q will be true. I hope that is clear. Yes. Now we have the by condition or the by implication. If P by condition Q is true, it will only be true if and only if P and Q are both true or P and Q are both false. Meaning that if I have the by implication and I have a sentence P and that P is true, then I have a Q, that Q is also true, then P by implication Q, meaning true by implication true, will be true. Again, if P is false and Q is false, then I have false by implication false being true. Please do not confuse the difference between the word true and then the truth value of a sentence. Okay, let's move on. So I've created a small table based on some of the connectives, the simple connectives that we have, where I'm looking at P, I'm looking at Q, I'm looking at a negative of P, and then I look at P and Q, I look at P or Q, I look at P implying Q, and then P by implication Q. So this table is based on the semantics and the PL that I just explained. It would make a bit of sense. Thank you very much for your time. Don't forget to drop your questions if you have any, and we will come back with the concluding part of this lecture.